All right, we are live. All right, so hi, I am Lonnie Souder. I'm here volunteering for the Mechanical March um, series that Exercism is putting on now. Just a little bit about myself here. Um, I do C++ and CUDA work for my main job here. I've been doing this for about 5-ish years now. Um, so yeah, we are going to be streaming the Allergies exercise for C++. Um, so just I guess, yeah, we could just get right into it. So for the allergies, or for any exercise, assuming you have Exercism CLI tool installed, you can go right to the page. You can just copy this guy right over here and paste that into your terminal, and bam, it downloads the exercise, all the files you need, right to right to your local drive. Um, and they even tell you where they download it right here, which is convenient for that. Um, I'm going to be working in VS Code today. Doesn't really matter, other than if you want to follow along, you'll see some stuff in here. Um, so we're just going to get that set up. I'm going to zoom way the heck in, and let's open up some files. Actually, before we get going too far, sorry about that. Where is it? And just for anyone joining, I'm going to put some of my own personal info up here. So if anyone wants to contact me later, questions, comments, concerns, I've got my email up here for anything related to this, or not, why not? And I also do have a recent blog that I'm promoting at the moment. So feel free to go over there, check out some intro stuff on Git right now. But yeah, other than that, let's get right into it. All right, so when you start up Exercism, all you're going to need to build and run these exercises locally is CMake, which is free and all that fun stuff. Yes, so let's bring up CMake. Let's get me a terminal here. Cool. So for CMake, for those that haven't used it before, it builds in 2 steps. You're going to do first a configure step and then an actual build step. And then they also include some other tools for running tests and such. Yeah, so first we're going to do CMake dash capital B. It's got to be capital. This is just going to tell us what directory to put the build in, and I'm going to tell it put this in a directory called build. And then for actually running all the tests here, there is a special variable that Exercism uses that I like to keep defined. And you can find that in this CMake list.txt over here. So the variable is exercism run all tests. Pretty straightforward stuff there. And so when you configure, when you want to define a variable via the command line, you're going to do -d for define. And then you're going to go ahead and put the name of the variable and then equals whatever you want it to be equal to. In this case, it's a Boolean. I want it to be on, so I'm going to do true. For CMake, it'll take a 1 for true. It'll take on. It'll take true. Um, it hardly matters. So yeah, we're going to turn on the tests, and we're going to say build. The last argument is just the directory of basically the top level CMake file, which is here. So my directory is here. We're going to do a dot. So this is going to go, it's going to configure. I'm on Windows, so it's selecting the Visual Studio's suite of compilers and such. If you're on Linux, this also works, and Mac, it should work as well. It'll just use different compilers. It's not that big of a deal. Anyhow, so now we are configured, and the next step would be do cmake --build. And tell it to build the build directory. Or better yet, we'll actually go into the build directory. We can say cmake --build. That's in the way. We say this directory is what we're building, and it's going to go ahead and it's going to start trying to compile things. And we go, oh my goodness, there's a whole bunch of errors. Well, that is because we haven't actually written any code. But that's how that's going to work. So let's actually go in and write the code this thing is looking for. So we don't need CMake open anymore. You shouldn't have to make any modifications to the CMake list.txt for any of these. If you do, something may be wrong. Right. So allergies. They're going to work. I'm going to make this just a little bit smaller because that's huge. And we're also going to open up the CPP file. I'm going to close that out. All right. So the instructions for this exercise were told, given a person's allergy score, determine whether or not they are allergic to a given item and their full list of allergies. An allergy test produces a single numeric score which contains the information about all the allergies the person has that they were tested for, of course. The list of items and their value that were tested are as follows. We have eggs, peanuts, shellfish, strawberries, tomatoes, chocolate, pollen, cats, and they all have a numeric value assigned here. All right. So then they give the example. So if Tom is allergic to peanuts and chocolate, he gets a score of 34. So you'll see chocolate is 32. And the other one was peanuts. That is 2. So 2 plus 32 is going to get you a score of 34. Now, given that just a score of 34, your program should be able to say that Tom is allergic to any one of those allergens listed above. Or we should be able to say he's allergic. We should be able to give, okay. So they are saying, given the score of 32, we should be able to reverse that and say, all right, well, 32, that means chocolate and peanuts. Or if they say, hey, is Tom allergic to peanuts? We can say, yes, as a matter of fact, he is. So that's what they're asking for here. And then they just have a note about some, it's like a boundary case or something, but we don't need to worry about that too much. There's something else to note. So we need a function to satisfy both of these conditions. Hello? Both of these conditions over here. And if we were just to write any old function, it actually wouldn't work within Exercism. We have to define exactly what it is that they are looking for. So we're going to go ahead and look in this tests, allergy tests. That's what we want. So we will see that we have allergy test is some item. So basically in this test file, we're going to have a bunch of things that we are looking to test, essentially. So we're looking for something called an allergy test. It's a type of, it's going to be under namespace allergies, some type of allergy test. And we're looking for a function is allergic to, which looks like it takes a string. So given all that, can I just break that? There we go. We're going to close this side panel. We're going to, nope, I wanted that the other way. We can close this terminal for now. We don't need that for anything. And we can also, you know what? We've read the prompt. I'm going to go ahead and put that away for now. There we go. This is a little better. Apologies for making you watch me fiddle with this. All right, cool. So we know that we want to implement these things here. So first of all, we know that an allergy test is going to be something that we know that we want to be able to determine. Well, let's not even go there yet. Let's start with, for the record, I've solved this problem before, and I know where I want to go with this. I just want to kind of give you the thought process of how you solve this, instead of just writing out an answer. I don't know that that would be super helpful. So let's start with the fact that we know our, and see, I just got rid of this, and now I want it back. So we have all these items. We have some categories that are assigned to numbers. In C++, we have something that will, basically do that, I guess, conversion. It'll make that association for us. We call that an enum. And then there's kind of a special version that called an enum class, which is just a little bit safer. Um, it it kind of stops some automatic conversions, that would happen if you didn't, um, have it as a class. Otherwise, an enum just acts as an integer, which is fine for most cases, but it's not always quite as safe. Um, so anyway, we have an enum class, and we know that we want to call this, I guess we don't know that we want to call it anything yet. So let's just say these are, um, what are these? Allergens, I believe is the term. So these are things that you could be allergic to. We have eggs. Um, yeah, that's fine. We have eggs. We have peanuts. We have shellfish. We have strawberries, tomatoes, chocolate, pollen, and cats. All right, so we have all these things, and by default with an enum, if you just leave these things how they are and you don't give them any kind of special specifications, it just counts up. So eggs will be 0, peanuts will be 1, then 2, 3, 4, and so on. But that's not quite what we want. We actually have special numbers that we want these to be. So we're going to go ahead and set these like this. Ooh. And 128. All right. So here are our list of allergens. Um, so far, that just kind of, gives us this association. It doesn't really tell us anything. Well, we haven't solved the problem yet. We have some information. We've put that into code. We need to actually solve this problem, though. So now is when we need to look into the allergies test. Let's see what functions we need. So we need a way to create something called an allergy test. That's going to take a integer in. So let's go ahead and make that. That's pretty simple stuff here, right? Let's go ahead and we'll have a class. We'll call this allergy test. You do have to spell it right, or it will be angry at you. Cool. So this is gonna, this defines a class. It's called an allergy test. It's essentially a new data type with some methods on it for those that aren't familiar. All right, and then we're gonna define what is called a constructor. Um, Actually, before I even do that, I like to kind of template this out a little bit. Not template in the C++ sense, but essentially when you make a class, you want to have some things that are accessible, which you're going to label public. Um, and you want to have some things that you hide away from everyone, typically. And you're going to label them private. Really, the point of a class is that you can hide some things away um, while exposing only the specific functionality that you want. All right. So now we need to have some way that you can create an allergy test. This is called a constructor in C++. So the constructor, it just takes the name of the class, and it takes some data type. We'll call this takes a score, essentially, I believe. And you don't actually have to tell it to return anything because a constructor returns things. It returns an instance of itself. And I've missed a semicolon up there. Yes, okay. So we got no red squiggles now. So we don't even need to fill this in yet, necessarily. We just know that we need to have this function available to us. We don't necessarily care what it does yet. And then when we have a score, or I'm sorry, when we have an allergy test should have some ability to check, are we allergic to something? We have this function is allergic to, and it takes a string. So I'm going to go back to our header file, and we are going to make this public function. Takes a standard string. It's going to take an allergen. And this returns a Boolean. We're basically going to say, yes, they're allergic, or no, they are not allergic. All right, and so we have another red squiggle here. And also, I'm going to go ahead and make this const because this function is not going to do anything to change. Well, it shouldn't. All we're saying is we're looking at a score and saying, does this change anything? We're not actually modifying this object with this function. Therefore, we're going to say this is a const function. It doesn't change the allergy test. It just gets some information from it. And we have a red squiggle here because I goofed up. If you're going to be using the standard string class, you will also need to include that class. And that just looks like this for those that haven't used C++ before. We do pound include and then your header file. And we'll see this again in a minute. Right. All right, so there we go. Our red squiggles are gone and we can continue. So let's see, what else can our allergy test do before we implement any functionality? We have is allergic to, is allergic to, is allergic to, a whole bunch of calls to that. Aha, and now down here we have a get allergies. Interesting. So get allergies is expecting an unordered set. If you can kind of look at how this test goes. So this test is we make an allergy test with a score of 0, 0 meaning you're allergic to nothing. And then we say get allergies of that. And that should be equal, whatever that returns should be basically an empty unordered set like we're seeing up here. Which, so that's good to know. We're getting our inputs and outputs here. So I'm going to just copy get allergies, and you also notice get allergies does not take any inputs. So we'll talk about how that's going to work out. And before I make the same mistake, if you're going to use an unordered set, you will need to include that header as well. There we go. We're 20 minutes in already. We haven't written really much code at all. This is going to take a standard unordered set. Oh, man. And the items in this unordered set, when you see these little angled braces, um, that means we're dealing with a template function. So this unordered set is actually going to return a list of, or not a list, a set of strings. Set meaning you're not going to have any duplicates. So you can't have eggs twice, for instance. And just like the previous function, this get allergies function shouldn't actually do anything to modify our allergy test. So we're going to mark it as const. Cool. What else? What else? What else? So this is our public interface right here. This is everything that that we need to be able to do with this class essentially. So now we can actually go in there and start doing something useful with this. Right now, these don't do anything. They're not even implemented. So let's go ahead and implement them. Make it do something interesting. So over here, you're going to notice that we have this pound include allergies.h, which is the name of our header file that we just populated over here. Why am I missing? Expecting a semicolon. Sorry about that. The namespace doesn't get the semicolon. This class should get the semicolon. There we go. No red squiggles. We are good to go. All right. So basically, this includes our header file, which essentially what including does is copy and paste this entire file right up here. So when you compile this, the compiler is actually going to take in all of these CPP files if you set up your CMake list correctly. The compiler doesn't really mess with the headers. It only really messes with the headers in the sense that when it gets a CPP file, it will go through these includes and copy and paste those particular headers in. Then it will use that to compile the entire implementation. So basically, if I were to just go ahead and start doing allergy test in here, oh, well, let's comment this out for now. Without that, if I do an allergy test, we're going to get some red squiggles here because the compiler doesn't know anything about an allergy test. We haven't defined it within this file. So if we uncomment that include out, now we have defined our allergy test, and these red squiggles go away because we've already defined this over here, and we've now copy and pasted it up here. So that's how includes work. Hopefully some of that was useful and not just rambling. All right, so now we're going to define these functions that we put over there. So first of all, we are going to define our constructor. So right now, our constructor doesn't really have to do anything. It's just kind of here. Right now, it takes an integer and does nothing with it because we don't really know. But it's pretty safe to say at this point. I could wait till later, but I'll spoil it now. It's not that big of a deal. We're going to want to store that score somewhere. So under our, let's actually format all this first. There we go. Now this looks decent. So we're going to go ahead and say we want to store our score in here. That's going to be an int. I like to mark members with a little M. Sometimes you'll see an underscore. It hardly matters, but this is my preference, so I'm going to go with it. And actually, yeah, I'm just going to go ahead and do that. M score. So member called score. And then what we're going to do is we're going to have what's called an initializer list here. So you do a colon, and then you say the name of your member variable that you are initializing, and you're basically giving arguments to one of its constructors. So this is an int. The int constructor can take an int and assigns an int. It's not anything wildly crazy. Yeah, so this is just going to take our score. What this does, well, it's a function that takes an int and it assigns that same int to our member variable. You could also, typically constructors that are more complex will have something within these curly braces. It's a little bit small. Sorry about that. Typically, you'll have something in these curly braces, some kind of initialization code or something. But for this, we just need to set this member variable. So that's all we actually need there. We can move right along. I'm going to format this one too. So next on our list. So we've got a constructor. It sets an int. Now we need to start implementing these allergy tests. Functions. So is allergic to. This takes a standard string, const reference, which is called allergen. All right, so we have, what is wrong with this? Declaration is incompatible. Oh, we actually need to say bool, and you actually cannot redeclare it as const over here. It's already const. So that is going to declaration incompatible bool. Am I wrong? Can you do that? No. Okay, I guess you can. It's been a little while. Sure. So we're basically just taking our function signature and we are bringing it over here. All right, so how do we determine, given some string, how do we determine that we're allergic to something? And in this case, so we're actually going to switch things up a little bit. So I made an enum before. Basically, we need a way to convert a string to a number. So I don't really want this enum like I thought I did. I'm going to use a map. So if you've ever used Python, this is like a dictionary. You'll see it called map and other things. So we're going to have a standard map. And the other thing that we're going to do now is we actually don't need anyone to know this information from our header file. So we're going to actually move it over here. Just format that. And then, like I said, we don't really need an enum because we're not using these we're using these names, but we are using them everywhere as a string. So we want something that can convert a string to one of these numbers, not just kind of give a name to these numbers, if that makes any sense. So what we're going to do, this is not going to be an enum class anymore. It's going to be a standard map that is going to basically relate standard strings to ints. And we only need a little bit of cleanup on this to make that happen. actual string now. All right, cool. So now what we have is a map that will convert strings to some integer. So yeah, it's fine. We thought we wanted an enum before, but it's an iterative process. You change things as you go, and it was a relatively simple change to make. So yeah, so now we have allergens converting that. So now we can kind of see. Let's go ahead and do is allergic to. Yeah, let's implement this one. So we have a string, and actually, what I'm also going to do, I'm going to bring up some documentation because it's nice to know what we have available to us when you're using a map. Let's put that on this side for now. Let's just put all this together because you only need to see the one file. So if we do standard map, we will get this nice CPP reference website, which is super useful when you're writing C++. Um, all right. So this basically is going to tell us all of the members and methods that we have available to us when using a map. So basically, we are given an allergen, and we want to determine is that allergen included in the score. And to do that, there's something that you also kind of need to notice about the numbers that were selected. They weren't just kind of selected at random. Um, Let me just kind of make some room for comments here. Apologies for the delay here. All right. So um, essentially, numbers in the computer are always represented in binary. Um, so OB, just to say that this is binary code. So essentially, 1 is going to be the same as saying, how many bits do we have? 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to give us 8 bits here. So we have 1, 2, 3, 4, 1, 2, 3, 1. Actually, let's do it this way. All right, so 2 in binary looks like that. You got 3 or 4, 8, 16, 32, 64, and lastly 128. So what you'll notice is in each of these numbers, the representation only has a single 1. Um, and that's going to play a big role in how we are determining which um, which number is included in our score. Um, right. So yeah, what we are going to do is, I guess another part of that, what I should say is in your score. So we said before, if you were to have 2 allergies, you would sum these together. So what happens when you would add these together? So eggs and peanuts, you would have 1 plus 2. You would wind up with both of these would have 1. You'd have 1 1 at the end. Would be 3. So essentially, you just kind of you're doing what's called a bitwise AND, which is how we're going to solve this problem here. So if something were to contain all of these, you would have 1 1 1 1 1 1 1, which would mean every allergy is there. And you will see this used quite frequently, especially since we're doing mechanical march. You'll see this done a lot in like embedded code, to like turn on pins and stuff, set registers. I've seen it in GPU programming for kind of packing data into a single data type. Like if you have RGB colors, you want to put them all into a single integer. You can kind of hack it like that. You'll see this a lot more in low level code. Um, yeah, so that's why we're doing it from Mechanical March here. Right, so is allergic to. So we're going to say we want to know, first of all, with this allergen, what number is that equal to? So first of all, we want to say let's go ahead and do it this way. We're going to say allergens dot find this particular allergen that we passed in. We're going to say, I'm going to go ahead and use auto here. This returns an iterator. It's not super important that you understand what an iterator is at this point. It's essentially a pointer to the object. Right. So we're going to say auto. We're going to make it const, and we're going to call it, this is I for iterator. What do we call it? Allergens. We already called it allergen. We'll call it an allergen code. Um, for Yeah, that's a good enough name. Right. So now, if we even found this, so essentially, if you were to give this a string that wasn't included in here, it would return you something that points to the end of your data structure. Um, it's essentially pointing to nothing. So we're going to check to make sure we actually got something. So if I allergen code um, is equal to standard, so we don't have to do that. We can say allergens dot end. So this end function will give you an iterator pointing at the tail, essentially. So if we find the end, well then we're done because that allergy doesn't even exist here. And then, wow, we're returning false because it doesn't exist. So we don't know if they're allergic to this. Right. Otherwise, we continue on as if everything is all good. So then basically we take this allergen code. I believe it should, let's see, what does that point us to? I think it might give us a tuple. Yeah, so it does give us a tuple back. So I'm actually going to go ahead and say, I don't actually know which compiler we're using. I don't know if we support structured binding, so I'm not going to do that at all. Basically, so this I allergen code is an iterator pointing to one of these items. So if you do I allergen code first, you're going to get this string. If you do dot second, you're going to get the number. That's all you need to know here. Right. So then, whether or not this is contained in there is, yeah, it's going to be one of these bitwise operators. It's going to give us a bool. So we're going to say if I allergen code dot second, remember this is that integer code. We did this and this and our m score. That's what we're going to return right there. So essentially, this is saying the bitwise AND operator is going to return. It's going to return a number where everywhere where both places have a 1 will also be 1. So just a little example here. If you had 011 and let's say 110 for the sake of having the example. So the first place has a 0 and a 1. So because both of them are not 1, that place would be a 0. The second place has 1 and 1, which, that means both of them are 1. So we get a 1. And then the next place is 1 and a 0. So again, both of them are not 1. So we will have 0 there. Right. And so integers are what they call kind of like um, they can be easily converted to a bool. So I don't actually believe I have to do anything here. As long as if this integer is 0, this will return false. But if any of these codes hit a hit on this score, if they have any bits alike, then this will return true because it'll right. It essentially is if so our allergy code is chocolate. If they both have a 1, if our score has the 32 place marked, then this will return 32 essentially, which will be true. Right. So we don't need to belabor that too much more. That is how we check um, if we are allergic to a particular thing. Let's go ahead and move on to the next function because I think we are slowly running out of time here. I am eating up lots of time with frivolous explanations. Right. So then the last thing is get allergies, right? So we're going to go ahead and I'm just kind of pasting in some boilerplate kind of code here. Right. All right, so let's go ahead and format that. Awesome. So now we have, essentially, we want to take an unordered set. Um, well, okay, so we know we want to return an unordered set. So let's just go ahead and start with that. We need to actually initialize one. We're going to call this, we're saying get allergies. So we're going to call it allergies, actually. And it's empty when we start out. So then what we're going to do to say, we have some score, um, and we want to decide which things are we allergic to. We want to return all of those. And the way we're going to do that is we're going to iterate through our allergens map that we have up here. And we're going to just kind of keep checking using these bitwise ands. We're going to say, are you allergic to this one? How about this one? How about this one? And every time we find something that we're allergic to, we're going to add it to that set. Um, so let's go right ahead. I'm going to say for auto construct allergen in allergens. This is essentially a for each loop. You should have seen these in lots of other languages. And we know we're going to be populating this in here. At the very end, we're just going to say we're going to return allergies. We know that now. So now what we're going to do is we're going to go through and we're going to say um, if allergen second um, and our M score again. So this is how we check to see if the allergen is included in the score. We check the allergy score and against our total score. So if that is in the score, sorry, we're going to take the allergen dot first, which is the name of the allergen. Sorry, we're going to say allergies dot insert, and we're going to say allergen dot first, which is the name, like I just said. Um, right. So that is the whole function. So we initialize an empty set. We say, okay, is this allergy? We go through each allergen. We check, is this allergen in our score? If it is, we add it to the set. And when we're all done, we return that set. Right. So I believe that's everything we actually have to implement. I'm just going to go ahead and run my auto formatter. We are going to open up a terminal and let's try to run some code. Um, so we did do CMake before. We've already configured this project. And when we tried to build, we got complete garbage. So they're going to try that same command again, cmake dash dash build dot. And let's see what we get this time. We should, oh man. Interesting. So we do have a compilation error. We have allergies, allergy test, illegal member initialization. M score is not a base or member. What on earth? M score. Illegal member initialization. Isn't it though? Here's a class allergy test. Here's our member right there. So what is missing here? So usually this code would work. I'm not sure what I'm missing. This is not the best way to go about this, but let's see if this fixes our problem for the sake of time here. Let's go ahead and try that again. Very, very interesting. We're within a class. Weird. Um, right, so if we wind up having time, we will try to figure out why it is that that other syntax didn't work. Usually that initializer list thing would be fine. But oh well. Right, so this actually on the build, it looks like it already ran our tests. In the event that it didn't, what we would do, CMake actually includes a tool called ctest, which will run all of the tests that you register with it. So I actually need to give it a directory. No tests were found. All right, so I guess we don't use ctest. That is interesting. Okay. No problem there. Some projects are just built a little bit differently. Um, so yeah, it looks like as long as you configure with the run all tests, when you build Exercism, the C++ project, it will actually run your tests for you. In this case, we've already passed all of our tests, so nothing more that has to be done. Um, let's see if there's anything else we can talk about here that we can clean some things up. Um, let's see. So I guess one thing we could do, since we do have the time, we can talk about some other tools that are included in C++ for you. Um, there is a tool that I'm not going to actually use, but I can show you how to. If you want to look up Doxygen, let's just put notes up here. Doxygen. That's how you spell it right there. If you look up Doxygen, there's Doxygen is basically a tool you can use to generate documentation for you automatically, which is great, and all of your coworkers will thank you if you do this. But essentially, oh, this is nice. I didn't know I had that installed. Essentially, you kind of use this format. You make a block comment over your function, um, and then you have these special little at tags that specify what kind of information you're giving. Um, so the only thing here we need to fill in is, I actually apparently had a plugin that auto fills this for me. But we just need to describe what the heck is this score that we're asking for this function. So this is just a total allergy score, or sum of. Yeah, that's fine. We don't need to say sum of. We know what a total is here. So yeah, that's how you write a document comment for that one. We can do the same for every public facing function. Um, this is a great plugin. I like that. Right. So is allergic to will um, it determines um, whether or not we are allergic to allergen. The allergen is a string specifying. We don't need to say that's a string. It's the name of an allergen, right? And this returns true if we are allergic, and false if we are not allergic. And obviously, this is all super simple stuff that doesn't really require documentation, but it's good practice to do this type of thing, and it doesn't hurt. It makes your code look super professional. Um, so this gets the allergies object. That's not actually true. This plugin is saying that it's noticing that it's a get function. That's not really what we want here. So what this does, this will um, produces a, what are we going to call that? A set of all allergies. Yeah. It produces a set of all allergies that are included in our allergy score. This returns an unordered set. Um, yeah, we could actually just say copy and paste this right here. We can format that. Oh, that's not what I wanted. Format document. That'll just kind of get rid of some of those funny line breaks for us. Right, and then we have documentation for everything that someone can see. The reason we do that for the header is typically when you compile this into a library or something, you will distribute compiled binaries and headers. All of this code will not actually, all this code in the CPP file I'm referring to, that actually won't really be seen by any customers. It'll just be seen by your coworkers. Um, so there's no need to give this type of documentation for it. Although every once in a while, like if you do something crazy, like maybe this is a really complicated function here, you could actually pull this out into a private function, or we could just make a little note and say, this determines whether or not an allergen is present. And then when your coworker goes through and sees this, they go, oh yeah, that's what this crazy thing does. Um, and they won't have to go dig through documentation and figure anything. It'll all just be there. Right. Well, I don't think I have very much else to say about this one. So we can save both of these. I guess we should actually submit it. So we did start this out with the Exercism CLI, and we can do now. I actually forget how to submit something. So when we're done, we would do Exercism submit. That's the one. So from our working directory for this exercise, we're going to do exercism submit. And I believe this takes a list of files that we want to submit. In this case, we want to submit our allergies.cpp and our allergies.h. You shouldn't need to submit any other code unless for some reason you had other files there. So right, we can submit that, and it says our code is up here. Let's go ahead and follow that link. We will see that I have submitted a problem. We have iterations up here. It actually failed. That's interesting because we passed the tests locally. Let's see what failed. We have an extra semicolon, huh? On allergies CPP 19. Yeah, that shouldn't be there. That's a good catch. So let's do cd build, cmake dash dash build dot. Make sure this tests properly for us locally. And then we're going to go back up and let's make sure I actually did save this. Yep, we're going to go ahead and submit that. We're going to go back and check to make sure everything is looking good. We have iteration 2. It is currently running our tests. And show me something. All right, well, anyway, that, we saw it pass the test. Eventually, it should say, hey, you passed the test, and you can request mentoring, in which case I may mentor your problem. Or you might get one of the other very talented mentors or something like that. But yeah, so that's the process for using Exercism. This is how you use bitwise operators. If you're kind of curious and fuzzy on how this funny business actually worked, Google bitwise operators, and it'll make probably a little more sense with a more in-depth explanation. Yeah, but that's all we have today. So I'm Lonnie Souder, signing off. Thanks.